So most questions about logistic equations are going to ask us about when the population reaches a certain amount or when it's increasing by the most, and let's just kind of get a brief survey of what we might expect to see right here. So when it says how many fish are there at the beginning, so this is the number of fish in a pond is given by this equation. How many fish are there at the beginning? Well, remember this equation, we plug in t here, it gives us the number of fish here, so we can just plug in 0 here and we'll get our answer. So n of 0 is equal to 100 divided by 1 plus 49 e to the negative 0.03 times 0, which is 100 divided by 1 plus 49, because this thing is 1, this thing right here. And so then we'll have 100 over 50, and that's just going to be equal to 2. So we start off with just with 2 fish. And how many fish are there at the end? Well, we started off with these 2 fish. And you'd think we might need to plug something in here, but remember, one of the facts we know about these logistic equations is that this top number, that's kind of the maximum number I reach, right? It looks something like that. So there's nothing to plug in here, you just write down 100. L is equal to 100, the number on top. Now here's kind of a trickier problem. So at what time is the population of fish growing most rapidly? And so one of the facts that we remember from our introduction is that the population is growing most rapidly when the population is equal to L over 2. So what we want to know is, when is P of t equal to 100 divided by 2? When is P of t equal to 50? Right, and that will tell us when the population is. That will tell us the value of time t when the population of the fish is growing most rapidly. So what we'd want to do here is we'd start with our equation, 100 divided by 1 plus 49 e to the negative 0.03 t, and we want to know when this thing is 50. So we're just going to solve this, right? And the way we'll start off by doing that is we will multiply this over to that side, and we will divide each side by 50. So we'll have 100 divided by 50 is equal to 1 plus 49 e to the negative 0.03 t. This is equal to 2. I'm going to subtract 1, so 2 minus 1 is equal to 49 e to the negative 0.03 t. And now I'm going to divide each side by 49. So we'll have 1 over 49 is equal to e to the negative 0.03 t. And where is my variable here? It's in an exponent, so I need to take an ln, and I'll end up with the ln of 1 over 49 is equal to negative 0.03 t ln e. This is equal to 1, and I divide each side by negative 0.03 to get t is equal to the ln 1 over 49 divided by negative 0.03. Now if you plug that into your calculator, you will get 129.727. And so that would be your answer for the time when the population of the fish is growing most rapidly. It's growing most rapidly when the population is 50, and that occurs when t is equal to 129.727. Now if it asks you something about when will the pond be a quarter full, what does it mean 1/4 full? So the way we want to think of this is think back to B. So when is the pond full? Well, when it's 100. So when it's saying when is it a quarter full, we want P of t to be equal to 1/4 times 100, times my max, which is equal to 25. Now, to solve this equation, it's going to be very similar to this. We'd start off with our original equation, 1 plus 49 e to the negative 0.03 t equals 25. And we'd go through the same steps we did here. All right, so we'd go through the same steps, and we'd end up with something very similar to this, right? So we'd actually end up with t is equal to the ln of 3 divided by 49 divided by negative 0.03, which if you plug that into your calculator, you would get 93.107. And so just a reminder that these things are that you use the same steps as above to solve it. And finally, let's look at something like this. So at what rate, the key word here is rate, is the number of fish increasing after 5 days? So my equation is P of t, or N of t, is equal to 100 divided by 1 plus 49 e to the negative 0.03t, but it's asking about the rate, not the population. And so remember, rate always means derivative. So it's just asking about the derivative at t equals 5. So to solve this, we need to find the derivative of this equation, and the way we need to do that is with the quotient rule, right? So we have f and g, and the quotient rule says the derivative is going to be f prime g minus f g prime divided by g squared, which in this case is going to be equal to f prime is 0, so this term is 0 times g, so 1 plus 49 e to the negative 0.03 squared, or 0.03t, this doesn't matter too much because it's times 0, and then we'll do minus 100 times g prime. So remember, g prime, we're going to have a chain rule with this, so we'll have 49 times negative 0.03 e to the negative 0.03 t. And then this is all going to be divided by g squared, so 1 plus 49 e to the negative 0.03 t squared. If you want to simplify this a little bit, there's not a ton you can do, but you'll have 100 times 49 times 0.03, and if you did that in your calculator, you would get 147 e to the negative 0.03 t divided by g squared, so 1 plus 49 e to the negative 0.03 t squared. Now, so to get your rate at 5 days, you'd plug in t equals 5 to get that p prime of 5 is equal to 0.0679, and this would be fish per unit of time, so we'll say fish per day. Okay, so big ideas with this logistic function. This number on top is your maximum. The way this original function works is that you plug in a t, you get the population. And so if it's asking about the rate at which the population is changing, that's asking about the derivative.